Good morning. Happy Friday. The following Zoom session is being recorded and will appear later today on my YouTube channel, Math with Mayo. Therefore, when you participate in the Zoom meeting, if you do not wish for your picture or your name to be made public, please leave the video off and use an alias name. If you have questions during the meeting but do not wish to speak, email me at bmail@ybcc.edu. and I will respond as soon as I can. All right, so today we're going to start chapter 10. Give me just a second here. Yes, the recording is working. And there. We're going to start chapter 10. So we're going to look at section 10.1. And we're going to look at two things. First of all, the square root property. And second of all, completing the square. Let's say we have the following problem. W squared minus 47 equals 0. Now, back in chapter 6, we factored and we'd look at this and say, oh, it might be the difference of two squares, but since 47 isn't a nice perfect square, we would say it wasn't factorable, but we're going to look at a different way of solving this equation today. We're going to put it in the form where on the left side of the equation, we have a perfect square, which contains a variable. And on the right side of the equation, we have a constant, okay? So to do that, we'd add 47 to both sides of the equation. Now we're going to use the square root property. Think back to chapter 9, where we had equations containing one or more radicals. And like, let's say it had the square root of something equals some number and we'd square both sides of the equation. Well, now we're going to take the square root of both sides of the equation. So W squared equals 47. We'll take the square root of both sides. Okay, we're going to come back to this in a minute. Let's go back to something easy that we know. Let's say we had x squared minus 9 equals 0. Okay, and we could factor that. And we get x plus 3 times x minus 3 equals 0. And then we'd go on and we'd solve it, setting each thing up. We get x is -3 and x is +3. So we get x is -3 and +3. That would be using factoring back in chapter 6. Okay. In fact, let's just come back to this one. So now, let's do the same problem, but using this new method. This new method, we'd add 9 to both sides of the equation. We get x squared equals 9, okay? Then we'd take the square root of both sides, and we get x equals 3. But wait a minute, we already determined that there were two solutions. So to accommodate for that, what we do is this. In the process, when we take the square root of both sides of the equation, we put a plus minus sign in front of the radical. So we get x equals plus or minus 3. And that plus or minus is an accepted mathematical notation. Web sign doesn't use it, however, so they would have the two answers listed separately and separated by a comma. Okay. All right, now let's go back and take a look at that one I put up there before. W squared minus 47 equals 0. We're going to add 47 to both sides of the equation. W squared equals 47. We're going to take the square root of both sides. Don't forget the plus or minus. Now, 47 is not a perfect square and does not contain any perfect square factors other than 1. So our two answers, W equals the square root of 47 and negative the square root of 47. Okay, let's take a look at another problem. Let's say we've got u squared minus 24 equals 0. So again, we need to get it in that form where we have a perfect square on the left side of the equation and a constant on the right side of the equation. Next, we take the square root of both sides. Don't forget the plus or minus on the right side. So we get this. However, since we've learned how to simplify a radical, we will continue to do that with our answers. The square root of 24 is the square root of 4 times 6, which is 2 square roots of 6. So u equals plus or minus 2 square roots of 6. U equals 2 square roots of 6, comma, negative 2 square roots of 6. And those would be your two answers. Okay. Now, let's say we've got something like this. X plus 1, the quantity squared, equals 4. This is already in that special form. On the left side of the equation, we have a perfect square that contains a variable. And on the right side, we have a constant. So we'll take the square root of both sides of the equation. On the left side, we get x minus 1. On the right side, we get plus or minus 2, because the square root of 4 is 2. However, we're not done because we haven't solved for x yet. So now I need to add 1 to both sides of the equation. So x is 1 plus or minus 2, which means x is 1 plus 2, which is 3, or x is 1 minus 2, which is negative 1. So x equals 3 and negative 1. Okay, let's see here. This says, let f of x equal x plus 5, the quantity squared. For what value or values of x is f of x equal to 3? So we're going to substitute 3 in the place of f of x. So we'll get x plus 5, the quantity squared, equals 3. We'll take the square root of both sides of the equation, plus or minus. We get x plus 5 equals plus or minus the square root of 3. Then we'll subtract 5 from both sides. X is negative 5 plus or minus the square root of 3. So x is negative 5 plus the square root of 3, negative 5 minus the square root of 3. Again, if we were in the classroom using pencil and paper, we could write it like this. But in WebAssign, we need to write them as two separate solutions. Okay, now, recall back in chapter 6, we looked at perfect square trinomials. Trinomials that had two identical factors. For instance, x squared plus 6x plus 9 is a perfect square trinomial. X plus 3 times x plus 3, or x plus 3, the quantity squared. This is the kind of thing we're looking for in this process so that we can take the square root of it and get back to x plus 3. So what we're going to do now is called completing the square. Suppose we have the following, x squared plus 24x. If I want to manipulate this expression and turn it into a perfect square trinomial, I use the following process. I take the coefficient of x, so that's the 24. I divide it by 2. I then take that number and square it, and that becomes my constant term. X squared plus 24x plus 124 is equal to x plus 12 times x plus 12, or x plus 12, the quantity squared. So I've created a perfect square trinomial. Let's take a look at another example. Let's say I've got a squared minus 7a, and I want to manipulate this expression and change it into a perfect square trinomial. I take the coefficient of the linear term, the first degree term, in other words, the negative 7. I divide it by 2, which is negative 7 halves, and I square it, which is 49 fourths. And then I add it to that. Now I have a perfect square trinomial that is a minus 7 halves times a minus 7 halves, or a minus 7 halves, the quantity squared. So again, I take this coefficient, divide it by 2, take the result and square it, add it here, and I get a perfect square trinomial. Okay, let's take a look at one more of these. Let's say I've got this x squared plus 2/5 x. Well, now things get a little bit trickier because 2/5 divided by 2 is 2/5 divided by 2 is 2/5 times the reciprocal 1/2, which reduces down to 1/5. Or you could just say half of 2/5 is 1/5, if you can see it that way. Then we're going to take that and square it, and we get 1/25. So this becomes x plus 1/5 times x plus 1/5, or x plus 1/5, the quantity squared. And again, we've created a perfect square trinomial. Again, why do we want to do that? Because to use this square root property, we need to have one side of the equation a perfect square trinomial. Okay, now let's see here. Let's take this equation, x squared minus 6x minus 4 equals 0. So now instead of dealing with an expression and doing what's necessary to turn it into a perfect square, we're going to deal with an actual equation. Because of that, to solve this, anything we do to one side of the equation, we must do to the other side of the equation. Okay? So the first thing we're going to do here is we're going to take the constant and move it over to the right side of the equation. Then I'm going to rewrite the equation, but I'm going to leave a space here. Okay? And the reason for that is this. Now, I'm going to take the left side of the equation and turn it into a perfect square trinomial. So I take the -6, coefficient of x, divide it by 2, which is -3. I square that, which is 9, and I add 9 to the left side of the equation to turn it into a perfect square trinomial. But because it's an equation, I also have to add 9 to the right side of the equation. Now on the left side, I have x minus 3, the quantity squared, and on the right side, 13. Something to help me remember what goes here, it's going to be x and then whatever's in here, so minus 3. Okay, now let's get rid of that. So I've got a perfect square containing a variable equals a constant. I'm going to take the square root of both sides of the equation. Don't forget the plus minus. So x minus 3 is plus or minus the square root of 13. Add 3 to both sides. X equals 3 plus or minus the square root of 13. So x is 3 plus the square root of 13, comma, 3 minus the square root of 13. And there's your two solutions. Okay, now, if we were to try to factor this equation using the techniques from chapter 6, we wouldn't be able to do it because we can't do it using rational numbers. And we typically limit factoring to rational numbers. So to get these solutions, we need to use a process like this. Okay, let's take a look at another example. This says x squared minus 18x plus 2 equals 0. So I'm going to start out by moving the 2 to the right side of the equation. X squared minus 18x equals -2. I'm going to take the coefficient of x, cut it in half, square it, and add that number to both sides of the equation. On the left side, I now have x minus 9, the quantity squared, and on the right side, I have 79. Okay, taking the square root of both sides, I get x minus 9, equals plus or minus the square root of 79. Adding 9 to both sides, x equals 9 plus or minus the square root of 79. Now, 79 is prime, so I can't simplify that radical any, but let's go on and do this. Let's find decimal approximations to the nearest hundredth. Okay, so we've got 9 plus the square root of 9 plus the square root of 79. And I get 17.88819, etc. And it said round to the nearest hundredth. Let's see here. So that would be what, 17.89, because this 8 would round up. So there's my first answer. And then my second answer, 0.1118, rounding to the nearest hundredth would be 0.11. So 17.89 and 0.11 would be the solutions to the nearest hundredth. Okay, now that's not the whole story though. These last two examples had a coefficient, a leading coefficient of a 1. So here and then here. Let's say the leading coefficient is not a 1. So let's take this equation, 2x squared minus 5x plus 2 equals 0. So now we've got to deal with the whole situation. And this whole process is on page 831 in the regular textbook. I'm not sure about the ebook, but it has the whole process of completing the square to solve a quadratic equation in the variable x, it says. But we're going to go through that now. So the first thing we want to do, we want to have a leading coefficient of a 1. And it's not, it's a 2. So what I'm going to do is I'm going to divide each term on both sides of the equation by the coefficient of the leading term, unless that coefficient is already a 1. Okay, so thinking in terms of ax squared plus bx plus c equals 0, you would divide everybody by a unless a is already 1. Okay, all right, now this gives me x squared minus 5 halves x plus 1 equals 0. The next step is to move the constant term to the right side of the equation. So I'll subtract 1 from both sides. Okay. The next step is to take the coefficient of x, which is negative 5 halves, and divide it by 2, cut it in half, which is negative 5 halves divided by 2, which is negative 5 halves times 1 over 2, which is negative 5/4. Then square that and add that to both sides of the equation. By going through this process, I have now created a perfect square trinomial on the left side of the equation. And it's going to be x minus 5/4, the quantity squared. On the right side of the equation, I need to combine those two numbers. We've got negative 1 over 1 plus 25 over 16. Let's see. The common denominator there would be 16. So we'll multiply by 16 over 16, which gives me negative 16/16 plus 25/16, which is 9/16. Okay. So now I've got x minus 5/4, the quantity squared, equals 9/16. I've completed the square, everything's tidied up. Now I'm going to go back and finish the problem. Rather than going, well, yeah, we'll just go ahead and go to the next page. So I've got x minus 5/4, the quantity squared, equals 9/16. I'm going to take the square root of both sides of the equation. Don't forget the plus minus. So I get x minus 5/4 equals plus or minus 3/4. The square root of 9 is 3. The square root of 16 is 4. Now I'm going to add 5/4 to both sides of the equation. So x equals 5/4 plus or minus 3/4. So we've got 5/4 plus 3/4, which is 8/4, which is 2, or 5/4 minus 3/4, which is 2/4, or 1/2. So x equals 2 and x equals 1/2. Okay. And let's see here. I'd ask if there's any questions, but there's no one here to ask. Let's take a look at another example. 5m squared plus 13m minus 6 equals 0. So the first thing we want to do is get a leading coefficient of a 1. So we're going to divide each term by the coefficient of m squared, which is 5. This gives us m squared plus 13/5 m minus 6/5 equals 0. The next step is to move the constant term to the other side of the equation. So we'll add 6/5 to both sides. Okay. The next step, let's make that a little nicer, is to take the coefficient of m and divide it by 2. So we're going to divide by 2, which is like multiplying by 1/2, which becomes 13/10. Okay. We're going to take 13/10 and square it. We get 169 over 100. So we're going to add that quantity to both sides of the equation. On the left side of the equation, I now have m plus 13 over 10, the quantity squared. On the right side of the equation, I need a common denominator, which is 100. So I get what? 120 over 100 plus 169 over 100, which is 289 over 100. So I get m plus 13/10 squared equals 289 over 100. So now I've completed the square. I'm going to take that and go to the next page. M plus 13/10, the quantity squared, equals 289 over 100. Now, taking the square root of both sides, on the left side, we get m plus 13/10. On the right side, we get plus or minus, let's see, I think 289 is like 17 squared. Let's see here. The square root of 289. Yeah, so that's 17 over 10. The square root of 100 is 10. Okay. Now we're going to subtract 13/10. So I get m equals negative 13/10 plus or minus 17/10. So m equals negative 13/10 plus 17/10, which would be 4/10 or 2/5. M is negative 13/10 minus 17/10, which is negative 30/10 or negative 3. So m equals 2/5, comma, or negative 3. And let's see here. 5m squared. Where did there it is. Okay. Just wanted to find my place again. Now it says, use completing the square to solve each equation, approximate each solution to the nearest hundredth. So now we're going to get answers that are not so nice, and then we'll use a calculator. So let's say we've got this. 6x squared minus 12x plus 1 equals 0. All right. The first thing we're going to do is get the leading coefficient to be a 1. So since it's a 6, we'll divide each term on both sides of the equal sign by the coefficient of x, which in this of x squared, which is 6. So now I've got x squared minus 2x plus 1/6 equals 0. So if the leading coefficient isn't a 1, divide everything by whatever it is so that it becomes a 1. Next, move the constant term, whatever it is, to the right side of the equation. Again, don't forget to leave a gap to put in that next number we're going to find. Now, take the coefficient of x, in this case, -2, divide it by 2, square the results, and add that to both sides of the equation. At this point, on the left side of the equation, I have a perfect square, trinomial. On the right side of the equation, I need to clean things up. I'm going to multiply by 6/6, so I get -1/6 plus 6/6, which is 5/6. So I get x minus 1, the quantity squared, equals 5/6. So I've now completed the square. Okay, I'm going to take that and copy it on the next page. X minus 1 squared equals 5/6. Take the square root of both sides of the equation. Don't forget the plus or minus. I get x minus 1 equals plus or minus the square root of 5/6. I'm going to add 1 to both sides of the equation. X equals 1 plus or minus the square root of 5/6. Okay, let's see here. Where did I get this from? This one here. Okay. Now, let's see how we could deal with this. This is the same thing as 1 plus or minus the square root of 5 over the square root of 6, right? And we could go, if we just wanted the decimal approximations, we could split it up into 2 separate answers and find them. But let's clean this up first. So I now have an expression with an irrational denominator. I'm going to multiply this by the square root of 6 over the square root of 6. So now x equals 1 plus or minus the square root of what? 30 over 6. Okay, square root of 30 over 6. I'm going to put these into a nice package. So I need a common denominator, which is 6. So I'm going to multiply the 1 by 6 over 6. So I get that. And now I can write it like this. Now, do you have to do that in WebAssign? I don't think so. But I wanted you to be used to what they tend to do in mathematics. If you're writing it all out in pencil and paper, they write it as a nice single fraction package. Okay. Now let's take that and go to the next page. X equals 6 plus or minus the square root of 30 all over 6. So we get x equals 6 plus the square root of 30 all over 6. X equals 6 minus the square root of 30 all over 6. So those would be the 2 exact solutions. Now, to get decimal approximations, we need to do the following. We want to divide everything in the numerator by the denominator. So we're going to start with parentheses 6 plus the square root of 30, close parentheses, divided by 6. But on some calculators, when you put in a square root symbol, it gives you a left-hand parentheses. In fact, the one that I'm using, the TI 30X Roman numeral 2 S for solar, does that. So I'm going to have an additional set of parentheses there, because otherwise I get 6 plus that. If I put in 30 and then I close it, I haven't really closed the entire numerator. I've just closed up this radical. So again, I want to do it like I've done here. Okay. So left-hand parentheses, 6 plus the square root of 30, close up the radical, close up the entire thing, divided by 6, and I get 1.9128, etc. but it said to round to the nearest hundredth. So that's the hundredth spot. The 2 would round down. So 1.91 would be one of the answers. And then 6 minus the square root of 30. Again, that extra set of parentheses there. And we get 0.08712 to the nearest hundredth. Let's see, the 7 is in the thousandths place. It would round up. So we get 1.91 and 0.09 as our two approximate solutions. Okay, let's see here. Let's take a look at some more examples. Here we have 5x minus 2 the quantity squared equals 64. Well, this is already in that special form. We have a perfect square trinomial on the left side of the equation equals a constant on the right side of the equation. So we'll take the square root of both sides of the equation. On the left side, the square and the square root undo each other. We get 5x minus 2 equals plus or minus. The square root of 64 is 8. Then we'll add 2 to both sides of the equation. 5x equals 2 plus or minus 8. Then we'll divide both sides of the equation by 5. X equals 2 plus or minus 8 all over 5. Because these have nice numbers, we can take it out further. 2 plus 8 over 5, which is 10 over 5, or 2. 2 minus 8 over 5, which is negative 6/5. So x is 2, x is negative 6/5. Okay, let's take a look at this one. 9n squared equals 99. Well, in fact, this is already in that form because 9n squared is a perfect square. So if we take the square root of 9n squared plus or minus the square root of 99, on the left side, we get 3n. On the right side, well, let's see, 99 would be 9 times 11, so that would be 3 square roots of 11. Okay. Then we would divide both sides by 3. So n is plus or minus the square root of 11. N equals the square root of 11, comma, negative the square root of 11. And if we want to do decimal approximations, let's see here. The square root of 11 would be 3.316, so 3.32. And the square root of negative 11 would be negative 3.32. Okay. Let's see here. Out this one. 2m squared minus 8m equals 1. Our leading coefficient is a 2. So our first move is going to be to divide everybody by 2. So m squared minus 4m equals 1/2. I want to leave a gap there because I don't need to move the constant term over, which would be my next step, because it's already over on the right-hand side. So the coefficient of m divided by 2 squared added to both sides would look like that. On the left side, I've got m minus 2 the quantity squared. On the right side, I've got what? 9 halves. 4.5, 9 halves, okay? Take the square root of both sides. I get m minus 2 equals plus or minus 3 over the square root of 2, okay? I'm going to add 2 to both sides. M equals 2 plus or minus this, plus or minus 3 over the square root of 2. I'm going to rationalize the denominator of that fraction. So m equals 2 plus or minus 3 square roots of 2 over 2. Now, again, putting that into a nice little package, the common denominator is a 2. So I'm going to multiply this by 2 over 2, which makes this a 4. So then I get m equals 4 plus or minus 3 square roots of 2 all over 2. So there's your nice package answer. Let's take that to the next page. M equals 4 plus or minus 3 square roots of 2 all over 2. Okay, so that's would be the way you would write it as a single package deal on paper. But let's put that into separate answers. Oops. I'm still making a mess of it. And then let's go to the calculator. So, parentheses. 4 plus 3 square roots of 2. Close up the whole thing divided by 2. So 4 plus 3 square roots of 2. Close up the whole thing divided by 2, and I'm getting 4.1213. So 4.12 to the nearest hundredth. And then the second one, 4 minus 3 square roots of 2 divided by 2 comes out to negative 0.1213, so negative 0.12. So here are the exact answers, and here are the decimal approximations. Okay, so for over the weekend, section 10.1, you're going to be looking at the square root property and completing the square. I'll be back at 1:15 with an office hour should you have questions. Otherwise, have a great weekend, and I'll see you on Monday.